All unit. All unit. We've been dealing with what type of triangle? A right triangle. Doesn't it seem a little ridiculous that to use all this stuff, I can only use it in a right triangle? Like, how many times really are we going to have a right triangle? Probably not too often. You know, what if I just give you a regular triangle and I say, all right, that's 6, 32, 48. Hey, I want to find this side now. But we don't have anything to find that side, do we? We only have things to find sides in what type of triangles? Right triangles until today. All right, I'm going to show you a device that can be used in any triangle to find sides or angles. Okay, in any triangle. And that is called law of sines. All right, it's a formula I'm going to give you guys in a second. All right, called the law of sines, which can be used in any single triangle you want. Here's what I'm going to have to do. You're going to go back in a second, but you already have example 1 up there. Look at that. Okay. Solve triangle ABC. What have we talked about? Solve it. What am I asking for at the end? Whatever's missing. Whatever angle's missing, whatever side's missing. So you look at this triangle right here. Can we just at least find angle C? We don't need any special sine, cosine, Pythag, Hills or SAS to find angle C. So go ahead right now, find angle C. When you're ready, let's roll 23. Oh, picking on you, Kate. 30. Yep, 30 degrees. Okay, now we need to find the sides. Hills and SAS, why is that a no-go? It's not even a right triangle. 30, 60, 45, 45. I'm going through everything we've done. Sine, cosine, tangent. Okay, it's not a right triangle. But we have now what is called the law of sines that will help us find it. Here is the law of sines. Just so you know, it's not on the formula sheet. This is something when we take the unit test next week or the week after, we're going to have to remember. This can be used for any triangle. If you want to make a note of that, can be used in any triangle, right triangle or not. It's a proportion. It's a proportion. Just let me write it down and let me explain it before you start getting nuts. A, lowercase a, over the sine of uppercase A is equal to B over the sine of capital B. What's this all? What? Or I just put it up there. What did I just say before I put it up there? What do you need now? Clearly had a hand raised.
This is how I stretch.
Again, now this is your second time speaking this year in class and brought nothing to the class. Once again. I'm only going to give you one more opportunity. And then that's it. All right, here we go. A, B, these are sides in the triangle. Sides. A and B are sides in the triangle. Capital A is the angle across from that side. All right? B is the angle across from the side you put up in the numerator. Okay? These are always opposite each other. So these are sides, A and B. The sine of A is the angle across from the side you put up here. It'll make much more sense once we put actual numbers for this problem. Okay, here we go. Give me a side that is given in the problem up there. What only side I know? Dan, AC, how long is it? 28. So here's what we can do. We can say 28 over, what's the angle across from it? Okay, but I'm not just going to put 40. Sine of 40. Everyone see, side, angle across is equal to. Okay, now we have a class decision to make because there's two missing sides. Give me a side. Okay, so we'll put A over sine of, what's across from 110. So does everyone see law of sines right now? Side over the angle equals side over the angle. And now how do I solve this? Cross multiply. So I'm going to do sine of 40 times A is equal to 28 times the sine of 110. How do I get the A by itself so I could solve for it? Divide both sides by sine of 40. And notice I haven't asked you guys to go to the calculator yet, because I would probably wait to the very end where we are now and just put all this right now into a fraction template. All right, or you can do it separately. You can do 28 times sine of 110, then divide that answer by sine of 40. It's up to you. But I'd probably put this all in one fraction template right now. And I got to go back up. Rounding directions, round your final answers to the nearest tenth. So I get the alpha y equals out. I do 28 sine, make sure you're in degree mode, 110. And I divide that by the sine of 40. And just make sure we're all on the same page. What are you getting? 24? Good, 40.9 for side A. All right, now we have to find the other side, which is side C. Unfortunately, can't do Pythag, right? Don't have a right triangle, can't use Pythag. But we can use law of sines. Can we still use 28 and sine of 40? Sure. I'd probably recommend that versus what we just found, because if you made a mistake, you're going to make a mistake here. All right, so keep the 28 over sine 40. But now I'm going to do C over, what's the angle across from angle C? What's the side C? What's the angle there? 30 we just found, so I'm going to put sine of 30. And the only mistake I see with kids using law of sines is they forget the word sine there. All right, don't just put the degree measure, it's the sine of the degree. We cross multiply. 28 times sine 30 equals sine 40 times C. Hopefully you guys are dividing both sides by sine of 40. And what do we end up getting? 30. Only one, but how do we feel? Right? I know it's only one. How do we feel? All right, because there's a lot more. There's a lot more we can do with law of sines. Okay, a lot more than just find a side. We okay now before we keep rolling? All right, let's go. All right, looks like we're going to have to draw our own triangle here. So I got triangle DAT. Angle D is 27 degrees. Angle A is $1.05. T. Okay, now we got to talk. There's a little something that comes up you might not be familiar with. Everyone see this right here? Lowercase t. Thoughts on what you think that is? Yep, go ahead. Side across from angle T. That's the side. If you anytime you see the lowercase letters, that's the side across from the angle. So in this case, this is the side across from angle T is 21. And we're going to find a d, lowercase d. Everyone see lowercase d? So this side. Okay, it's not a right triangle. So we go right into law of sines today. I don't have to solve it, which is nice. Do you know a side and an angle across? I can first put in here. A side and an angle across. Give me a side and an angle across here. 29, you're up. Ooh, whoa, whoa. How'd you get 48? Okay, does everyone see? I'm not even going to involve the 105. It's 21 over the sine of the angle across, and I'm glad Dan did that. You got to put the sine with it. Sine of 48. Everyone all right? 180 degrees, so you may have to find that before you plug it in. And give me another side and angle across in that problem. 13, you're up. What? What side you're going to give me? I got 21. What's the other side in the problem? D over sine 27. Miss Lynch getting loud. Trying to compete with this guy. What do you divide both sides by? Sine of 48. $29, what do you get in here? Nearest integer, nice job. 13, any issues? 13. No comments either, huh? Especially from this crew. Okay. We just used that triangle right there. Never mind. Never mind. Dat triangle. DH dat. That triangle. No. All right. Okay. All right. Okay, here we go. Another one of those solve the triangle. You can find angle C. Let's just take care of the third angle right now. I got 30, I got 45, 105 for angle C. I'll walk around and see what you guys are doing to find side B and side A. I'm going to do one more, by the way, after this. I'm going to add in another one. Okay, I'm going to add in example 4. Because there's one thing else I need you guys to be able to do. Should be getting side A is 5 when you calculate it. Side B is 7. Anybody need some help here setting up those ratios before I get to this last beast? We're all good. Okay, if you set up example 4 for me, please. Example 4. And just draw a triangle. You're going to have to add this one in for me. Hopefully you didn't write too big on example 3. Add in example 4 for me, please. Okay, let's go triangle DEF. Everyone ready? Side F is 6. Angle D, 32 degrees. Side D, 5. Find angle F to the nearest degree. You can use law of sines not only to find sides, but also angles. So here we go. Still going to be a proportion. Set up one side for me. I'll go back in a second. Set up one side. 28, set up one side for me. Nice. Thank you for putting not just X, the sine of X. And how about the other side? 12. How about the other side? There we go. I'm still going to do what here to solve? Okay, let's see what happens at the end, and maybe you guys have a solution. I hope you do. 6 times the sine of 32 is equal to 5 times the sine of X. How do I get the 5 out of there? Okay, divide both sides by 5. I get the sine of X is equal to whatever decimal that comes out to be, right? Are you finding a side or an angle? An angle. You're going to get point whatever. That's not the angle. All right, that's not the angle. Let me do it with you. 6 sine, what was it? 32 divided by 5. Okay, that's not the angle. That's not the angle. How have we been finding angles in this unit? How do I find angle X? How do I find angle X? I got to do inverse. Yes, that decimal is not my angle. So I have to do second sine. And I can just either highlight the answer and paste it. I don't know if you guys ever knew this before, but above your negative sign, you have the word ANS, which is short for answer, and the calculator will just plug it in there for you. So that's not changing. If you have to find an angle, you have to do the inverse at the end. And this tells us that angle is going to be 39 degrees. So X is going to be inverse sine of 6 times the sine of 32 all over 5. X is 39 degrees. Again, can be used on any triangle. Can be used on any triangle. Questions with that one? If you have to find an angle, just think to yourself, inverse, especially going into tomorrow too. All right, as soon as you guys come in tomorrow, I'm just going to hand you the quiz. All right. Homework's due on Monday. Regents questions due on Monday.